Hey guys, so in this video I want to go over the first 4 lessons for Unit 4. And I'm sorry if I need to take a second to cough. As most of you know, I was sick Friday and still fighting off a sinus infection. So let's look at Lesson 1, number 3 to start off. So in this Lesson 1, our goal is to factor out each little part, cancel out any common factors, meaning a factor both in the numerator and denominator, and then simplify or put everything together that is left after canceling out what is the same. So let's look at number 3. Number 3, the first part we are looking at is 3x minus 6. And we're asking ourselves that flowchart that we created in Unit 3. Do we have a GCF? Yes, so let's factor it out. Our GCF is 3. So 3x divided by our GCF is x. Then we have negative 6. Negative 6 divided by our GCF is negative 2. Our next part is our 5x plus 15. Our GCF is 5x, or our terms that we're looking for our GCF is 5x and 15. So our GCF is 5. Each term divided by our GCF gives us x plus 3. Next part that we're looking at is 2x plus 6. GCF is coming from looking at 2x and 6. GCF should be 2 because 2 can go into both 2 and our 6. So 2x divided by our GCF gives us just x. Our 6 divided by our GCF gives us positive 3. And then lastly, we're looking at our 4x plus 8. GCF should be 4. And then dividing each term, it gives us x plus 2. So then overall, our result comes from multiplying it straight across. So in the numerator, we have 3 times x minus 2 times 5 times x plus 3. In the denominator, we have 2 times x plus 3 times 4 times x plus 2. And then we're looking to see if we have anything in the numerator that matches the denominator. So we do not have a 3, so we can't cancel out the 3. Do we have an x minus 2 in both the numerator and the denominator? No, we do have an x plus 2, but not an x minus 2. We don't have a 5 in the numerator, or in the denominator, so we can't cancel out the 5. And the x plus 3. We do have an x plus 3 in both numerator and denominator, so we can cancel it out. Then our result is 3 times x minus 2 times 5 all over 2 times 4 times x plus 2. So we're going to simplify this. Because multiplication is commutative, we can go ahead and combine 3 and 15, or 3 and 5. So 3 times 5 is 15 times our x minus 2 all over, again we can go ahead and combine our 2 and our 4 to give us 8 times x plus 2. We do need to take a second and see if we can simplify this fraction, and we cannot. So we can distribute our 15 to get 15x minus 30 in the numerator, and our denominator distributing the 8 to get 8x plus 16. And that would be our result for number 3. Now looking at number 4 for lesson 1. We're going to take each little section and factor it as far as we can, and then see if there's a common factor in both the numerator and denominator. So the first part is 2x plus 6. Asking ourselves, is there a GCF? Yes, it is a 2. Now 2x divided by 2 gives us x. 6 divided by our GCF gives us positive 3. Our next part is x squared minus 4, where we have a variable minus a number. So we're going to have two sets of parentheses. It's called difference of squares. The variable that is squared we put in the first part of each parentheses. We have a plus and a minus. And then we're going to take the square root of the number. So what times itself is 4? Well, it's 2. So that gives us our factor form of our second part. Our third part, we're trying to factor it. So is there a GCF? No. So next question is, does A equal 1? Yes. Our understood A is 1. So we can go straight to our big X method. Our B is understood 1. Our C is negative 6. So we want two numbers that multiply to give us 6, but also add and subtract to give us 1. If you cannot see the numbers, you can always do a t-table. So the smallest number that can go into 6 is 1. So 1 times 6 gives us 6. Next number that can go into 6 is 2. 2 times 3 gives us 6. Then you're looking at these sets of numbers and asking yourselves, can it add or subtract to give you that 1 or our B? So can 1 and 6 give you 1? No. So that's not your magic numbers. Can you add or subtract 2 and 3 to get 1? Yes. So 2 and 3. You want to use 2 times 3 to give you negative 6. You also want to add 2 and 3 to give us 1. Which one needs to be negative to make both statements true? The 2. So negative 2 plus 3 does give you positive 1. Negative 2 times 3 does give you negative 6. So your magic numbers are negative 2 and positive 3. So this third part becomes parentheses x minus 2 times x. Sorry guys for technical difficulties. So this third part becomes x minus 2 times x plus 3. So it's no longer x squared plus x minus 6. And then lastly, our 2x cannot factor it out anymore, so it stays 2x. So this gives us the result, multiplying straight across because it's multiplication. We have 2 times x plus 3 times x plus 2 times x minus 2 all over x minus 2 times x plus 3 times 2x. So we want to cancel anything that we can out that is both in the numerator and denominator. There is that x plus 3, so we want to cancel those out. We also have x minus 2 in both the numerator and denominator. We also have a 2 in both the numerator and denominator. So we're left in the numerator with x plus 2, and in the denominator we have just x. So we can stop there as our answer. Then we go on to 9. 9 is a little bit scary, but if you go ahead and rewrite the problem, rewriting this second or fraction bar into a division sign should look a little bit less scary. With this, it only has one extra step to it from what we've been doing. Instead of keeping it as two fractions and dividing in the middle, you're actually going to keep, change, change, or keep, change, flip, depending on which one you like to use. Keep, change, change, or keep, change, flip. So you're going to keep the first fraction the exact same. You're going to change the division to multiplication. You're going to change or flip the second fraction by changing the denominator to the numerator and the numerator to the denominator. And then you're going to do the exact same thing that we did with the last few. And that will complete what you need to know for lesson 1. For lesson 2. Lesson 2, you're solving rational equations. So there are 2 ways to solve these. Either you find the LCD, or the least common denominator, or you cross multiply if you have 2 fractions that equal each other. So in this case we do. So let's start by looking at the cross multiplication way to solve. In this one, we're going to cross multiply 7 and x minus 5. So 7 times x minus 5. And we're going to set it equal to our 6 times x plus 2. So 6 times x plus 2. So we're going to simplify both sides as far as we can and solve for x. So we have 7x minus 35 equals 6x, 6 times x, and then 6 times 2 is 12. And then we're going to move the 35 over by addition because it's negative right now. And the negative 35 plus 35 cancels out. We also can move the 6x over by subtraction. The 6x minus 6x cancels out. And we're left with x equals 47. So that is our example of cross multiplication. Again, this only works when you have a fraction equals a fraction. Now, to look at one that is not a fraction equals a fraction, for number 2. This is where you're having to look at your LCD, or your least common denominator. Well, we have 5, 3, and then an understood denominator of 1. So we want the LCD. We have 5, 3, and 1. Well, what is the smallest number that 5, 3, and 1 can go into? Not what is the smallest number that can go into 5, 3, and 1. What is a number that all three numbers can go into evenly? Meaning I can divide it and it become a whole number. Well, the number should be 15. There is not a smaller number than 15 that both 5, 3, and 1 can go into evenly. So I want to come in here and look to see what do I need to multiply 5 by to get to our LCD. I have to multiply by 3. If I multiply the denominator by 3, I have to multiply the numerator by 3. Same thing with the other fractions. The 3, what do I have to multiply by to get to our LCD? I have to multiply by 5. What I do in the denominator, I have to do to the numerator. For the 1, what do I have to multiply by to get to my LCD? I have to multiply by 15. So I also have to multiply the numerator by 15. So that means the first fraction becomes 3 times 4x minus 3 over 15. Then I have subtraction. Then my second fraction becomes 5 times 4 minus 2x all over 15. Then I have equals 15 over 15. So what this ends up being is that once our denominators are the exact same, we can ignore them. So we end up with 3 times 4x, which gives us 12x. 3 times negative 3 gives us negative 9. Subtract 5 times 4 gives us 20. 5 times negative 2 gives us negative 10x. And then equals 15. And we solve for x. Remembering that because we have a negative in between these two expressions, we do have to distribute this negative inside of the parentheses. So we have 12x minus 9 minus 20 plus 10x equals 15. So simplified, we get 22x minus 29 equals 15 plus 29 on both sides. To move that 29 away from the 22x, 22x equals 44. Divide by 22, x equals positive 2. So that is our answer for number 2. Remember, if I go too fast, please feel free to pause it. If you have any additional questions, make sure you email me or ask questions in class. So, before we do lesson 3, take a second and write these steps and scenarios down. So, for the vertical asymptotes, you have step 1, set the denominator equal to 0, then solve for x. For your horizontal asymptotes, you'll either have case 1, 2, or 3, depending on where the biggest or smallest exponent is. Alright, so let's look at number 1 in lesson 3. So our vertical asymptote is only dealing with our denominator, which is x minus 3. So we want to look at x minus 3 equals 0. Well, solving for x, we're going to add 3 to get x by itself. Negative 3 plus 3 is 0, and 0 plus 3 is 3. So that is giving us our vertical asymptote. Now, our horizontal asymptote. Going back to our fraction. According to 1 over x minus 3, where's our biggest exponent? Well, our biggest exponent is in the denominator because there is no variable or exponent in the numerator. So if our biggest exponent is in the denominator, which case do we have? Let's go back to what we wrote down. Biggest exponent or biggest degree in the denominator looks like case 1. So a horizontal asymptote is going to be at y equals 0. Well, there's one thing that messes this up though. So if we were just looking at the fraction, our horizontal asymptote would be at y equals 0. But this plus 4 on the outside is going to affect our y's and is going to transform or translate all of our y values up by 4 because it's on the outside. So this actually is going to be a horizontal asymptote at y equals 4. And then we get into the wholes. So the wholes relate to if there is any common factors in the numerator and denominator. Is there any common factors between 0 and x minus 3 that are the same? No. One has just a number 1, the other one has x minus 3. If there's no common factors, you put none. So then you look at the vertical, horizontal asymptote, and the wholes to determine your domain and range. So you always start off with all real numbers, and I always tend to put not equal to. If there's going to be a vertical asymptote at 3, that means your graph is going to skip where x is 3. So your domain is not going to include x value of 3. For your range is going to be all real numbers except or not equal to your y value of 4 for your horizontal asymptote. If your horizontal asymptote is at 4, your graph is going to get really, really close to y is 4, but not actually touch it. So your range is going to be all real numbers except or not equal to 4. So let's look at 3. Number 3, for your vertical asymptote, again, you're only focused on your denominator. So 2x plus 6 equals 0. You're going to subtract 6 on both sides. You have 2x equals negative 6. Divide by 2, divide by 2. X equals negative 3. Then your horizontal asymptote, you're looking at your exponents. Well, one has an exponent of 1. The denominator has an exponent of 1. So they're the same exponent or same degree or same power. So let's look back at what we wrote at the beginning. If they're the same degree in the numerator and denominator, we're going to use our leading coefficients. So our leading coefficients for number 3 is going to come from an understood 1 in front of the x to the first, and our 2 in front of the x to the first in the denominator. So our horizontal asymptote is at y equals 1 over 2. than the holes in the graph. So we're going to factor every part that we can and determine if there's any holes or any common factors in the numerator and denominator. Well, can we factor x minus 1 anymore? No. In the denominator, can we factor 2x plus 6? Yes, because there is a GCF. GCF is 2, so we do 2x divided by our GCF, we get x, and 6 divided by our GCF, we get positive 3. Is there common factors in between x minus 1, 2 in the denominator, and x plus 3 in the denominator? No, there is not. So we have no or none holes. So when we look at our domain and range, we're looking at the first three things that we found. Always start with all real numbers. We're not going to include the x that we're skipping for our vertical asymptote, so not equal to -3. And then our range is going to include all real numbers except or not equal to our y value that we're skipping for our horizontal asymptote. So now let's look at number 5 in the notes to see what if we did have a hole and what if we didn't have a horizontal asymptote. So for the first thing, and remember, if I go too fast, you can always pause it. We always want to set our denominator equal to 0 to find our vertical asymptote. So we're going to look at our 4x squared plus 12x minus 16. And I'm going to come off to the side right here. We're going to ask ourselves, is there GCF? Yes. So we're going to factor out our GCF. Get x squared plus 3x minus 4. Now, does our a equal 1? Yes. So we can do our big X method. 3 and -4. And we're going to get positive 4 and -1. So our denominator is 4 times x plus 4 times x minus 1 equals 0. Well, to solve this, we're going to set our parentheses equal to 0. Again, this is what we did in Unit 3. X minus 1 equals 0. Subtract 4, subtract 4. X equals -4. X also equals positive 1. So that is going to be our two vertical asymptotes. Now for a horizontal asymptote, again, pause it if I'm going too fast. Horizontal asymptote, we are looking at our exponents, our biggest exponents. So our biggest exponent in the numerator is 3 versus our denominator biggest exponent is 2. So going back to our scenarios that we wrote down originally, if our biggest degree or biggest exponent is in the numerator, we have nothing or no horizontal asymptote. How I taught you guys to remember it is that if we have a huge thing on top of a really small thing is going to crush it into nothing. Or a big person sitting on a little small person, they're going to crush it into nothing. So for number 5 that we're looking at, if our biggest exponent is 3 in the numerator, then we're not going to have a horizontal asymptote. Now, for our wholes, we've got to determine if there's common factors. So we have to do that. We have to start by factoring both the numerator and denominator. So in the numerator, we do have a GCF that we can factor out, and it becomes 2 it becomes x times x minus 3 times x plus 4 all over, and we just factored the denominator, so it's the same thing that we just did. 4 times x plus 3, x plus 4 times x minus 1. So for our wholes in the graph, we are looking at the fact that we have x plus 4 in both the numerator and denominator. So we're first going to take the common factor and set it equal to 0 and solve for x. So minus 4 minus 4. X equals negative 4. So in our wholes, that is going to give us an ordered pair, so our x is negative 4. Then, without that common factor, we get x times x minus 3 all over 4 times x minus 1. So we're actually going to substitute this x value in for x everywhere that there's an x into our calculator. So we're going to have negative 4 times negative 4 minus 3 all over 4 times negative 4 minus 1. And we're going to do this in our calculator, so we're going to do parentheses negative 4 parentheses negative 4 minus 3, close the parentheses again to distinguish between the numerator versus the denominator. Then divide parentheses 4 parentheses negative 4 minus 1, close parentheses again to distinguish between the end of the denominator. And we get negative 7 over 5. And that is going to be our y value. So once we have found our wholes, we are looking at domain and range. Again, every single time is going to start with all real numbers. And then if we had a vertical asymptote, a horizontal asymptote, or a whole, we're going to have exceptions. So you can either write out except, or you can do the union sign of the infinity signs and the numbers. But the typical way I'm going to show you is the not equal to, because it's less writing. So a vertical asymptote tells us that our graph is not going to include x is negative 1, x is 1, or negative 4 and positive 1. It is also not going to include the negative 4 due to our wholes. So our domain is not equal to negative 4 and positive 1. Now our range. Our range, there was no horizontal asymptote. So from our horizontal asymptote, we are not skipping any y values. However, there is a hole that includes a y value of -7/5. So we are skipping that value for our holes. So that would be our number 5. Alright. So then lastly, lesson 4. Lesson 4 is a little bit more technical and less mathedy math stuff that we've been doing. So number 1. You're going to find the words varies inversely and circle it. Once you circle it, whatever is immediately in front of it, there it goes. Immediately in front of it is your y, immediately behind it is your x. So in this case, it just happens that it's y and x already. So you're substituting the values into y equals k over x. So you're finding k, so you already know that y equals 3 and x equals 4. You're not looking at x equals 18 right now because you don't know what y is when x is 18. So you only are focusing on the information that is given for both variables. So in this case, y is 3, k you do not know, but x is 4. So you're solving for x, or for k. Multiply by 4, multiply by 4, 4's cancel out, you get 12 equals k. So for number 1, k is always 12, every single time. Now we can look at where we have to find y when x is 18. So k is now 12, x is 18, and we want to know what y is. So we do y equals k, which is 12, over our 18. Now, can we simplify that fraction? We can. Both of them we can take out the same number, and it simplifies to 2 over 3. Now let's go on. Let's try a harder problem. So same thing, you want to find the words varies inversely. So here it is. In front of it, we have the frequency of a vibrating guitar string. So that's going to be our y. And then behind it is as its length. So that's our x. So the first sentence we're looking at is, suppose a guitar string is 0.65 meters long and vibrates at 4.3 times per second. So our x, our length, is 0.65. Our y is 4.3. Then what is the frequency, or our y, when our string is 0.5 meters long? So that is our length, that is our x. So we've got to use the set of data that is complete to find our x, or find our k first. So we're going to do y equals k over x, substitute our values in, 4.3 equals k over 0.65. Get k by itself, we have to multiply by 0.65. Multiply by 0.65. Cancels out. And we get 2.795 equals k. And again, this is for the whole problem, not just the set of data. So then we can use it to find our y. Y we do not know. X we have 2.795 all over our 0.5. So our y equals 5.59. And then lastly, number 7. Number 7, you're going to find the words varies inversely. Whatever is in front of it is your x, so the volume, or everything in front of it is your y, and the volume is your y, as the pressure is your x. As the volume of 32 is at the pressure, volume is y, pressure is at 8. We gotta find our k, so we're gonna do 32 equals k over 8, multiply by 8 to get k by itself, and we get 256 equals k. Then we look for the last part of that problem, find the pressure, so that pressure was x, when the volume, or the y, is 660. So y we know, k we know, and x we do not. So we gotta get x by itself. We cannot just multiply by x on both sides. This does not get rid of the 256, or you can't do multiply by 256. That does not cancel out the x, or that does not cancel out the 256. So what we actually need to do is multiply by x on both sides, get rid of the x, so we get 60 times x equals 256, and then we can divide by 60, and we get x equals 256 divided by 60, which gives us approximately 4.3. And that would be our answer for number 7. Again, if you have any questions, you can email me or